This is Vijayalakshmi Subnali from Venma's YouTube channel. Here, in this session, we have to discuss the multiple choice questions for second PUC in mathematics. Here, Venma's is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation with various competitive exams like CET, NEET, and J. Okay, here we have to start the session now. Here we will discuss the matrices chapters now. There is a first question. If A is a matrix of order 3 cross 4, then each row of A. Okay, here usually the order of the matrix. Okay, usually the order of matrix denotes here 3 cross 4. 3 means the number of rows. 3 indicates the number of rows and 4 indicates the number of columns. Number of columns. Okay. Mainly the order of matrix denotes the number of rows cross number of columns. Here there is a order 3 means there are 3 rows. There are 3 rows. Then each row of A, there are 3 rows means each row contain 4 elements because 4 columns are present. Here it is like this. There are 3 rows and 4 columns. The elements A11, A12, A13 and A14. A21, A22, A23, A24, A31, A32, A33, A34. This is the general representation of the matrix of order 3 cross 4. Okay. Here there are 3 rows. 1, 2, 3. These are the 3 rows. R1, R2, R2. And 4 columns. That is C1, C2, C3 and C4. There are 3 rows and 4 columns. Here each row of A. 1, 2, 3, 4. Each row contains 4 elements. Therefore, the answer is option number B, 4 elements. Similarly, for second question, if every row of a matrix A contains m elements and its column contained n elements, then order of A. Here, a row of matrix. Here, the row contains m elements and column contains n elements. Therefore, order of A is, order of the matrix A is m cross n. The number of rows always we have to write in a order of the matrix. First we have to write the row, after that column. The first m represents the number of elements in row and n represents the number of columns in column. So must and should the first element m shows the rows and n column. We have to writing the order of form. Must and should first write row and column. The option number B is correct. The order of A is m cross n. If the order of A is 4 cross 3 and the order of B is 4 cross 5, then what is the question will be incompleted here. That is, I will check once. Question number 3. Okay, here the order of A transpose B whole transpose. Okay, we have to find the order of this one. If here we already know that here A matrix, then transpose. This one represents the transpose matrix of A. Transpose of matrix can be defined by the number of rows and columns are interchanged. The number of rows and columns are interchanged, then we will get the transpose matrix. Here, first we have to consider the order of A matrix. Order of A matrix will be 4 cross 3. While taking the transpose, the order will be changes. The row will be changes to column and column changes to row. Then the order becomes 3 cross 4. Okay. Here, first A matrix of order 4 cross 3. While taking the transpose, the order will be changed. The number of rows and columns are interchanged. Then order will be changes here. Again, while taking the multiplication, here I will take the multiplication of A transpose into B. What is the order of the A transpose? That is 3 cross 4. And order of the B will be 4 cross 5. While taking the multiplication of two matrices, then there is this point will be same here. That is the first matrix of the column and the second matrix of the rows are equal. Then you will get the multiplication matrix, that is 3 cross 5. These are same. If when we have to take the multiplication, there is a must and should the number of columns of the first matrix is equals to the number of elements in the second matrix should be same. Then we will get the resultant matrix is the number of rows cross the number of columns of the second matrix. The resultant matrix 3 cross 5. That is A transpose B. Again, they want for this one transpose A transpose into B whole transpose. Then again the order will be changes here, that is 5 cross 3. Therefore, the resultant order of the matrix will be 5 cross 3. The option number D is correct. Then, if a matrix has a 8 elements, then total number of possible different orders of matrix. If matrix has 8 elements, okay, then the possible orders, okay, while taking the multiplication of 8 or the tables of 8, that is when we have to take 8 cross 1, okay, this is 8 elements. The number of elements present in the matrix. 8 cross 1, it means 8 elements are written in one column, then 1 cross 8, otherwise 2 cross 4 and 4 cross 2. Only 4 possible orders will be for 8 elements. Here, 8 elements are written in 8 rows, 1 column, otherwise 1 row, 8 columns. 2 fours are 2 rows, 4 columns. Then 4 rows, 2 columns. Here for this one, there are 4 possible orders. And the option number 4 is correct. Here, if a matrix has a 13 elements, the question number 5, if a matrix has a 13 elements, then total number of possible different order. Because here 13 is a prime number. Okay, 13 is a prime number. Therefore, there are only 2 order possible. That is 13 cross 1 or 1 cross 13. Here, there is a only 2 order. The given number of elements are taken in a prime number order. Then there is only 2 order will be present. Here, 13 rows, 1 column or 1 row, 13 columns. The option number B, 2 is present. Then next question. For any square matrix A is equals to Aij, for Aij is equals to 0. Here A represents the matrix. Here small letter Aij represent elements which is present in ith row, jth column. The element A present in ith row, jth column. Here Aij is equals to 0 when I is not equals to j. Then the matrix is a scalar matrix. By the definition of scalar matrix, that is A is equals to Aij. Aij is equals to 0 when I is not equals to j. Then for 2 cross 2 matrix. Okay. Here for 2 cross 2 matrix, A is equals to Aij whose elements are given by. Okay. We have to write the 2 cross 2 matrix by using this one form. Okay. First I can write the general form of the matrices of order 2. That is A11, A12, A21, A22. Here, this is of order 2 cross 2. There are 2 rows, 2 columns. Okay. Here, the first element, first row, A11 represents first row, first column. Okay. I will take here. For this one, I will substitute the values. Here, I value 1, J value 1. 1 plus 1, 2. 2 square will be 4. Okay. 2 square will be 4. I will calculate here. A11, A12, A13 and A14. Okay. 1 plus 1, 2. 2 square will be 4 by 2. 2 ones are 2 twos are. The value is 2. Similarly for A12, I value taken 1, J value 2. 1 plus 2, 3. 3 square will be 9. That is 9 by 2. Again, for this one element A21, sorry, I will taking here wrong. The elements. Okay, sorry. Hmm, I will, this is scalar matrix. I will take here, that is matrix containing the elements A11, A12, A1, A21, A22. I will taking the values here A11, A12, A21, A22. This one is, this is 4 by 2, 2 ones are 2 ones are 2, 2 twos are, will get 2. Again here 9 by 2. Similarly, I will take the 2 1. I value 2 plus j value 1. 2 plus 1 3 square 9 by 2. And 2 plus 2 4. 4 square will be 16. 16 by 2. I will get cancelled here. 2 ones are 2 eights are. The value is 8. Then I will substitute all the values here. A11 is 2. Here 9 by 2. 9 by 2 and 8. Comparing the answer, the option number C will be right answer. The option number C will be the right answer for the 7th question. Similarly for 8th question. For 2 cross 3 matrix, here this will represent 2 rows 3 columns. That is, I will take general, first general matrices, 2 rows. That is A11, A12, A13. A21, A22, A23. That is 2 rows, 3 columns. I will take the values here A11, A12, A13, A21, A22, A23. First one remains. Again 1 plus 1, 2 square by 2. That is 4 by 2, 2 ones are 2 twos are. The value is 2. Similarly 1 2. That is 1 plus 2, 3 square by 2. That is 9 by 2. Now 1 plus 3. Here I is 1, j is 3. 1 plus 3, 4. 4 square will be 16. 16 by 2. 2 ones are 2 eights are. The answer is 8. Similarly for this element 2 1, that is 9 by 2. For 2 2, that is again 16 by 2, get 8. 2 3. 2 plus 3, that is 5. 5 square is 25 by 2. Okay. All the values taken here in a matrix form, that is 2, 9 by 8, 8. Again 9 by 2, 8 and 25 by 2. Checking the options here. 2, 9 by 8, this one is neglect. 2, 9 by here, that is 9 by 2, 8. Again 9 by 2, 8, 25 by 2. The option number B is correct. Now, the question number 9. A row matrix has only. If a row matrix has a row matrix means only one row will be present irrespective of columns. Okay. Row matrix means one row will be present irrespective of columns. Here one element, the option wrong. One row with one or more columns. Yes, this is by the definition of row matrix. The option number B is correct. Here, while checking the option C, one column with one or more. No, one row and one column. This is not possible. Okay, then next question. Question number 10. A matrix A is equals to Aij. M cross N is said to be a square matrix. Square matrix means must and should the number of rows and number of columns are equal. Then the option number A is correct. If A and B are matrices of order M cross N. Okay, here A and B are matrices of order M cross N and N cross N respectively. Then which of the following are defined? Okay, here first I will check all the values here. Here A is a matrix of order and B is taken. And similarly, here A containing the order, that is M cross N. Here matrix B containing the order N cross N. By the definition of the multiplication, the second column of the matrix and the number of rows of the second matrix B, both are same, then the resultant matrix will be M cross N. This is possible. Okay. Similarly, for BA, here B and A matrix, the order of the B matrix, that is N cross N, and order of A matrix M cross N. Here, the by the definition of the matrices of two matrices of the multiplication, the number of columns of the first matrices and number of rows of the second matrices are different. Therefore, the multiplication is not possible. Okay, the option number A is wrong. Similarly, for AB. Okay, here already we know that AB is possible, but A square. Okay, A square means A into A matrix. What is the matrix? B cross N. Here also M cross N. Again, these are different. This is also not possible. For A square, here already we have checked the, that is by that one A square is not possible. What is the B square? B square means B into B. Then order of B matrix N cross N and again N cross N. By the definition of matrices, this is possible. So B square is possible. Then option number D. Okay. Here AB is the multiplication is possible and for B square is also possible. Therefore, by the definition of multiplication, the option D is correct because here AB and B square both are defined. But here there is no, here there is a only one order possible. That's why the option D is defined. Next, question number 12. The number of all possible matrices of order 3 cross 3 with each entry 0 and 1. Okay. Here there are 9 elements are there. Okay. 3 cross 3 means there are 9 elements are there. 9 elements are there. Then each entry 0 or 1. Okay. So the possible each entry, the possibility is 2. Each entry, the possibility is 2. Therefore, the number of possible the number of all possible matrices are 2 cross 9. That is 2 to the power 9. 2 to the power 9 means 512. While taking the multiplication, 2 to the power 9 means we have to multiply 2 for 9 times. The answer is 502. The option number D is possible. Next, the values of x and y make the following pair ij of matrices equal. Here, what are the values? Then, when two matrices are equal, then the first element of the first matrix and the second element of the RHS matrix are equal. Okay. Here we want x and y values. I will take only the first equation, that is 3x plus 7 is equals to 5. We want x value. That's why I will take x. Taking plus 7 on left side, it becomes minus 5 minus 7. Then minus 2. We want x value. X is equals to minus 2 by 3. Okay. Otherwise, you will check 2 minus 3x equals to 4. Both answers should be same. Okay. Now, again, we want the y values. I will take here y plus 1 is equals to 8. Y is equals to taking plus 1 on right side. It becomes minus. Y is equals to 7. Okay. Now, checking the option. The first option x is equals to minus 2 by 3. Yes, correct. Y is equals to 7. The option number is correct. The option number A is correct. X is equals to minus 2 by 3 and y is equals to 7. Here x value correct but y is wrong. Here both x is correct, y wrong. Here y correct, x is wrong. In the following scalar matrix. Okay. Then the matrix is said to be a scalar matrix. Then the non-diagonals must be 0 and diagonal elements are equal. Okay. By the definition of the scalar matrix, we have to say non-diagonal elements must be 0 and the diagonal elements are same. Then here for this option, there is a option number C is correct. Therefore, this is the scalar matrix. Next question. Question number 50. In the following diagonal matrix means it must be a square matrix. Okay. It must be a square matrix. This is not square matrix. I will neglect easily. Then again, diagonal matrix means the diagonal elements are present and non-diagonal elements are 0. Here there is a non-diagonal element must be 0. Here the option 3 is present. So I will neglect directly. Here the definition say the non-diagonal element should be 0. Here they are present. Therefore, the option number D is correct. Then, question number 16. If x plus y is equals to 5 to 0, 9 and x minus y matrix containing the elements 3, 6, 0, minus 1, then we have to find the x matrix. I will solve this one by using the equation method. Okay. So, I will add these two matrices. Okay. I will add these two matrices. We will get the x value. Okay. That is x plus y plus here minus 1. Okay, I will adding x plus y and x minus y. On left side, it becomes on right side 5 to 0, 9. Minus of this matrix, that is 3, 6, 0, 1 minus 1. Okay, here x plus x will get 2x matrix plus y minus y get cancelled. Again, I have to take the subtraction between these two matrices. 5 minus 3, it is 2. 2 minus 6, that is minus 4. 9 minus 0, 9. Sorry, 0 minus 0, it becomes 0. 9 minus into minus plus, that is 9 plus 1, 10. This is the 2x matrix. We want x matrix, so I will subtract by 2. We'll get 2 to get cancelled. This becomes 1. Here minus 2, 0 and 5. The x matrix will be 1 minus 2, 0, 5. While checking the options. Here 8, 8 not possible. 2 not possible. The option number C, 1 minus 2, 0, 5. The option number C will be the right answer for this matrix X. Similarly for 17 question. Okay, if A and B are two matrices such that if A plus B is equal to 7, 0, 2, 5 and the matrix A minus B containing the elements 3, 0, 0, 3, then the matrix A is, okay, here the matrix A is, we want A matrix. Similarly, I will add again, okay, I will take the addition here, A plus B minus A plus B addition plus A minus B is equal to the matrix containing the elements A plus B 7, 0, 2, 5 plus 3, 0, 0. B get cancelled here 2, 8. 7 plus 3, 10, 0 plus 0, 0, 2 plus 0, 2, 5 plus 3, 8. We want a matrix. I will divide each matrix by each element by 2. 5, 0, 1, 4. The A matrix should be 5, 0, 1, 4. The option number D is possible. The option number D is right for this one, matrix A. Next, the question number 18. If X is a matrix of order 2 cross N and Z is a matrix of order 2 cross P, if N is equals to P, then the order of the matrix 7x minus 5Z. Okay, here while taking the multiplication by scalar elements, this one is 7x minus 5z. Okay. While taking the multiplication by scalar element, then the order doesn't change. Okay. While multiplication matrix by the any scalar element or any number, then order doesn't change. The order of the matrix, it should be, order of the matrix should be 2 cross n and minus again 5 into z. Similarly, same result. Okay, that is 2 cross p. While taking the addition and subtraction, the order should be same. Okay, the order should be same. Otherwise, there is addition and subtraction is not possible. That's why n is equals to p. Then the resultant is 2 cross 2 cross p or else 2 cross n, because n is equals to p. You will take 2 cross n, otherwise 2 cross p while checking the option. Here p cross 2, this is not possible. 2 cross n. Okay, the option number B same. Again, n cross 3 not possible, p cross n not possible. If the answer is possible only 2 cross p or else 2 cross n. In between these two answers, the option number B is correct. For matrix A and B, for matrix A and B, AB is equals to 0. Then, okay, if while taking the multiplication between two matrix A and B, the answer should be 0. Okay, now A is equals to 0 or B is equals to 0. If any one of the matrix will be 0, otherwise any one of the matrix 0, then you will get the 0. Yes, definitely. Okay, and okay, this one is definitely. And but this is not possible all time. Okay, this is not possible all time. Therefore, the option number wrong. If A is equals to 0 or B is equals to 0 and A is equals to 0 and B is equals to 0. Yes, but this is also correct. But it is not necessary that A is equals to 0 or B is equals to 0. Yes, this the option number C is correct. Here A and B both possible, but it is not necessarily they in the option C, it is not necessarily A is equals to 0 or B is equals to 0 because I will taking the multiplication of this element 0, 1, 0, 0 and the matrix B is 2, 0, 0, 0 while taking the multiplication 0 into 2 that is 0, 1 into 0, 0. Again 0 into 0 while taking the multiplication it is 0. When if A is a matrix and B is also matrix then you will get 0. Therefore it is not necessarily A is equals to 0 or B is equals to 0. The option number C is correct. All above statements are wrong. No. The option number C is possible. Next question 20. If A is equals to element, the matrix containing the elements minus 1, 0, 2, 3, 1, 2 and the matrix B containing the elements minus 1, 5, 2, 7, 3, 10. Here A containing the order. There are 2 rows, 3 columns. Order of A is 2 cross 3. Here there is 3 rows and 2 columns. Now AB and BA both exist. I will check here. There is A and B. But order of the A matrix will be 2 cross 3 and order of matrix B is 2 rows. Sorry, here 3 rows, 2 columns. 1, 2, 3 rows, 2 columns. 3 rows, 2 columns. This is possible. AB must be possible. Similarly for BA, I will take BA. Order of B matrix 3 cross 2 and A matrix 2 cross 3. This is also possible. AB and BA both exist. The option number A is correct. The option number A is correct. Here AB exists but not BA. No, BA is also exists though. Therefore option B is wrong. BA exists but not AB. Yes, BA exists but AB is also exists but they given not. This option not. Both AB and BA do not exist. No, both exist. This one is also wrong. Therefore the option number A is correct. Which one of the matrix is not true? Okay, which one? There is a property. Matrix addition is commutative. Yes, while taking the addition. Commutative means matrix addition. That is A plus B and B plus A. Here, order of A and B must be same. Therefore, the addition is commutative. Matrix addition is associative. Yes, that is A plus B plus C is equals to A plus B plus C. Under the addition, that is associative. Matrix multiplication is commutative. No. Okay, this is uh, S. But matrix multiplication is not commutative. Here, AB is not equals to BA. Okay, here AB in between there is a multiplication. This is not possible. So option they given not true. Therefore option C is correct. Okay, they given they given negative statement. They given negative statement. Therefore option number C is correct. This is not possible. Matrix multiplication is associative. Yes, this is right. Therefore option C must be the right option for this one question. If 22, if A and B are two matrices, if A and B are two matrices such that A plus B and AB are both defined. Okay, here A plus B is defined. Plus B defined must should order same. Should order of the matrix will be same. Here if A is a M cross N matrix and B is also M cross N matrix. If both order is same, then it's satisfied. Then AB for A into B for AB matrix. Here I am taking same result. For one M cross A N. Here for this one M cross N. This is not possible for multiplication. Okay, it may be sometimes if both A and B are square matrix, it is possible. Otherwise, not possible. Okay, here I will check the option. If A and B are two matrices, not necessarily of same order. No. If both exist means the order will be same. Okay, the order will be same. Here not necessarily means A plus B possible, AB not possible. The option is wrong. A and B are square matrices of same order. Okay, this is also possible. Okay, this is also possible. Then because A and B are square matrix, I am already saying square matrix means A and B must and should M cross M. Here also M cross M. While taking the addition, it is possible. Similarly, for multiplication, M cross M. Here M cross M. This is possible. Therefore, if A plus B and AB both defined when A and B are square matrix of orders, same order. See, number of columns of A and number of rows of B. This is only possible for multiplication. For addition, this one is not possible. Option number D, none of these. Nothing. Okay. Next, if matrix of alpha is equals to cos alpha sin alpha minus sin alpha cos alpha. Then taking the multiplication, wherever alpha is there in element, we have to take the beta. After that, take the multiplication, you will get the result. Okay. So I will take the multiplication here, A into A alpha into B alpha. Okay. I will erase the some results here. Okay. Here A into alpha multiplication A into beta. That is A alpha means cos alpha sin alpha minus sin alpha cos alpha. Again between the multiplication A beta. Here this is A beta. So wherever alpha is there, I will change beta. That is cos beta sin beta minus sin beta cos beta. While taking the multiplication, cos into cos, that is cos alpha into cos beta. While taking the multiplication, row by column. This one is the row by column. First row, first column. That is cos alpha into cos beta. Plus, here plus into minus, it should be sin alpha into sin beta. Again, first row with second column, cos alpha into sin beta. I will taking here cos alpha into sin beta. Cos alpha into sin beta plus sin alpha into cos beta. For this one, second row, minus into second row with first column, minus sin alpha into cos beta. Again, this one sin into cos. Again, cos alpha into, here also minus cos alpha sin beta. For the second element, sin into sin minus sin alpha sin beta. Here plus cos alpha cos beta. While comparing the values by using the trigonometric function cos alpha cos beta minus sin alpha sin beta. So I will return this one cos alpha cos beta by using the trigonometric function, that is cos alpha plus beta. I will using the formula cos x plus cos of x plus y. Okay, here cos x cos y minus sin x sin y. In place of x and y, we have alpha and beta. Here cos alpha sin beta minus sin alpha cos beta. This is sine function, sine of alpha plus beta. Now here minus, I will take minus as a common, sin alpha cos beta. This one by using sin alpha minus beta and taking minus, it becomes plus. This one cos alpha, okay, cos alpha minus beta. This one cos alpha, that should be plus. I will take once here. Here, while taking cos alpha cos beta minus sin alpha sin beta, I will return cos alpha plus beta, cos alpha sin beta plus sin alpha cos beta. This one can be written as sin of alpha plus beta. Here taking minus common, then again sin alpha cos beta plus cos alpha sin beta. This is similarly for sine function. Again cos, here starting minus is there after plus. So again I will rewrite as a cos alpha cos beta minus sin alpha sin beta. This is of the cos formula. Okay. Now, comparing this multiplication with original matrix, then here cos, sin. In place of alpha, here alpha plus beta are there for both. So, I can take this one whole matrix can be written as, I will return whole matrix as A of alpha plus beta. This matrix is written as A of alpha plus beta. Therefore, the option number D is correct. Option number D is correct. Next, move on the questions. Let's move on the question number 24. For suitable matrices AB, the first statement is, okay. Here, while taking the A into B transpose, you will get the result A transpose B transpose. This is the first statement because while taking the transpose, you will get AB transpose should be B transpose into A transpose. Okay, this is the famous statement for matrices AB. Okay, therefore, this is the first statement. While checking the other options, A transpose whole transpose should be A. This one is right. A minus B transpose is equals to A transpose minus B transpose. Yes, A plus B transpose is equals to A transpose plus B transpose. This is also true statement. Therefore, option number A is the first statement. Next question number 25. If A is equals to 3x, y, 0, the matrix A containing the elements 3x, y, 0, and here there is a matrix should be is equals to A transpose. Okay, while taking the A transpose of this matrix should be 3 y 0 and 3 y x 0 while changing the rows into column, and here the second column. Then the values here x becomes y and y becomes x. Therefore, the option number C is correct. When x is equals to y, then it is possible. Next question number 26. Which one of the following is not true? Here A is a symmetric matrix if here AT not there, that means A transpose is equals to A. Okay, here this is the true statement. And A is a skew symmetric if A transpose is equals to minus A. This is also true statement. For any square matrix A with real number entries, A plus A transpose is a skew symmetric. No, it is not possible. A plus A transpose is a symmetric matrix, but they given skew symmetric. Therefore, this one is the not true. Okay, option number C is the right answer because this is the not true statement. Question number 27. A matrix containing the elements 0, 5, minus 7, 5, 0, 11, 7, minus 11, 0. Okay, here this matrix. Okay, this is the skew symmetric matrix. Here the elements. Okay, this is non-diagonal matrix because the non-diagonal 0, but here diagonals are 0. So this is also not scalar matrix. No, this is not scalar matrix. It should be a skew symmetric matrix because the elements. Okay, you will get the here. This is also minus. Okay, minus 5, minus 7, 5, 0, 11. The values, the non-diagonal elements, the values are taken as a negative. While taking the transpose matrix, the result should be A minus A transpose. That's why this is the skew symmetric matrix. Question number 20. Next question. If A is a symmetric as well as skew symmetric, a matrix is symmetric as well as skew symmetric, then it should be a null matrix. Then it should be a null matrix. If A and B are symmetric matrices, then same order. Both are the symmetric matrices. Okay, A is equals to A transpose and B is equals to B transpose. Then of the same order, then while taking the multiplication AB, then you will get A transpose into B transpose. Again, it can be A transpose into B transpose can be written as A in the B into A whole transpose. Okay, while using the result B into A whole transpose, then you will get the same matrix. Therefore, this is the null matrix. This is the null matrix. While taking AB is equals to BA. Okay. AB is equals to BA. Then taking AB minus BA should be 0. That is null matrix. Again, question number 30. If A is a matrix containing the elements 2, x minus 3, x minus 2, 3 minus 2 minus 1, 4 minus 1 minus 5 is a symmetric matrix. This is the symmetric matrix. Then x value. Here I will take A is equals to A transpose. This represents the symmetric matrix. I will return the transpose, then the elements, the rows can be written as a column. X minus 3, x minus 2. Again, 3 minus 2 minus 1 minus 1. Here, 4 minus 1 minus 5. This is the transpose. While if A is equals to A transpose means each element should be equal. That is, here 2 equal x minus 3, here 3. X minus 3 is equals to 3. Then x should be taking minus 3 on the right side. It becomes plus, then 3 plus 3, 6. Therefore, x value should be 6. The question number 13. If A is a square matrix, then A minus A transpose. A should be a square matrix, then A minus A transpose. Okay. Here I will take A minus A transpose should be null matrix. A minus A transpose should be a null matrix. Up to this much, the multiple choice questions of the matrices should be covered. I will cover all parts taken with one examples. So you have to prepare better, and thank you. Thank you for watching my channel. If you really like my channel, please share, comment and like on my channel, and please subscribe me. Okay. Thank you.